Okay, let's continue talking about the evolution of the universe. We are now ready to go into part 2. So in part 1, we started off with one fundamental force, tau, and at the end of part 1, we had 4 fundamental forces that controlled the universe. And we said that all throughout that time period, this is what the universe consisted of: quarks, antiquarks, symmetrical quarks, the leptons, the anti-leptons, the supersymmetrical leptons, dark matter, light, and then dark energy. So we didn't do anything with that. All we were saying was that the universe was so hot that it could spontaneously create these particles, and then these particles could go back together again, turn back into energy. And then that energy could spontaneously make these particles again. So that's been going on all throughout the time period where we started with tau and then we ended up with the 4 fundamental forces. Now we're ready to go into part 2. In part 2, we don't care about the fundamental forces. So from this point to today, there have been 4 fundamental forces that controls the universe. So now we're interested in what's going to become of all of these different particles up here. To keep track of what's happening to the particles, all you got to do is remember what is inside of what. So if you start with an atom and you hit it with a hammer, you break it apart into its nucleus and electrons. If you take the nucleus and you break it apart, you get the protons and neutrons, which are called nucleons. If you take a nucleon and you break it open, inside of it is going to be 3 quarks. So now let's reverse that. Start with quarks. They're going to make nucleons. The nucleons are going to make nuclei. The nuclei are going to make atoms. The atoms eventually are going to turn into stars. The stars are eventually going to turn into galaxies. Another way of looking at this is to think about, what if you take a piece of ice and you heat it? It turns into a liquid. If you heat a liquid, it turns into a gas. And if you heat a gas, it turns into a plasma, meaning the electrons come off. And you have these charged nuclei, and then that's what a plasma is. So now let's reverse that. If you take a plasma and you decrease the temperature on it, the electrons attach, and now you've got a gas. If you decrease the temperature, the gas comes together to make a liquid. If you decrease the temperature, the liquid comes together to make a solid. It's becoming more organized. So going from plasma to solid, matter becomes more organized. Going from a quark to galaxies, matter is becoming more organized. You might be worried about all of these numbers that I'm giving you right now, and then the numbers that I showed you when we talked about part 1. Well, out of part 1, the only number that you would need to know for purposes of the exam is the 10 to the negative 43rd seconds. And so what that represents is how far backwards can we go before the laws of physics break down. And so from the instant that the Big Bang occurred until 10 to the negative 43rd seconds, we don't know what the universe was like because the laws of physics broke down. But from this time to the present, we do understand how the universe evolved by using the current laws of physics. So I would like for you to know this number, but other than that, don't worry about all those other numbers that I showed you. All right, so let's proceed with part 2. So in part 2, we're going to start with this, and eventually we're going to end up with the universe that we know today. So this is going to take place 10 to the -5 seconds after the Big Bang. The temperature of the universe is cooled to 10 to the 12th Kelvin. The size of the universe is now up to 10 to the 42 meters across. Now look at the constituents of the universe and compare it to this thing up here. So that's what we're starting with. And you will notice now that there's still leptons, there are still anti-leptons, there are still all of this other stuff, but there's no longer any quarks. So what has happened is that the quarks are now confined to being inside protons and neutrons. So I'm just going to say over here that you still have protons, and you still have antiprotons, and you still have leptons, and you still have anti-leptons, and a bunch of other stuff. But that's all that I'm concerned with. So now the temperature of the universe has gotten so cold, if you consider that to be cold. So the universe is now so cold that quarks no longer can freely travel, and they are now confined inside of nucleons, such as protons and neutrons. So that a proton consists of 3 quarks, 3 permanent quarks that are inside of there. So I'll just say Q, Q, and then Q. And let's not worry about the ups and the downs on there, but it's got 3 quarks inside of it. So that's a proton. Okay, and then you could also still have antiprotons. So an antiproton would be an anti-quark, and then another anti-quark, and then that would make an antiproton. So that you still have matter and antimatter at this point, but no longer any free quarks. So the quarks can no longer exist by themselves. Now there are other particles that contain quarks. We just don't care about them. So for example, there was another kind of particle that consisted of a quark and an anti-quark glued together. And then there were other particles that consisted of like 5 quarks that were glued together, or 7 quarks. So let's not worry about those, and let's just concern ourselves with the protons, the antiprotons, the leptons, and the anti-leptons. Okay, but it's still plenty hot enough that energy can turn into protons and antiprotons, because E equals mc squared. So that if you've got enough energy, you can manufacture matter. You can manufacture matter and antimatter. And if matter and antimatter go together, they turn back into energy. So energy can create protons and antiprotons, and then when they go back together, they turn back into energy again. Okay, let's take a break, and when we come back, let's find out what happens to the leptons.